Our next topic is how to solve a pair of simultaneous linear inequalities. And in this case, we're given two or maybe even more inequalities, and we're looking for all of the values of x which satisfy both inequalities. So the approach is to solve both inequalities separately and then take the intersection of the solution sets. Now, even though this looks like one inequality, it is in fact two inequalities in disguise. So we're going to separate these. The first one is minus 3 is less than or equal to 2x plus 1. And the second one is 2x plus 1 is less than 4. And we're looking for the solution to this pair of inequalities, so we're looking for all x values which satisfy both this inequality and this inequality. So we first work on the solution set of this one. Again, it's a linear inequality, so we take all of the x's to one side and all of the constants to the other. So subtracting 1 from both sides, we get 2x is greater than or equal to minus 3 minus 1, or 2x is greater than or equal to minus 4. And now dividing both sides by 2, 2 is a positive number, so it doesn't change the sign there. We get x is greater than or equal to minus 4 over 2, or x is greater than or equal to minus 2. Now that's only the solution set to this first inequality, or the left-hand side of this inequality. We also need the solution set to the right-hand side, or 2x plus 1 is less than 4. And again, bringing all of the x's to one side and all of the constants to the other, that means subtracting 1 from both sides here, we get 2x is less than 3. And now I divide across by 2, I get x is less than 3 over 2. So the x values satisfying this inequality are all x less than 3 over 2, and the x values satisfying inequality 1 are x greater than or equal to minus 2, and the x values satisfying both inequalities is the intersection of these two sets. So the solution to the pair of simultaneous inequalities 1 and 2 are all x values so that minus 2 is less than or equal to x, which is less than 3 over 2. So it's everything in that interval, and if I wanted to be precise, I would say it's the set of all x in the real numbers such that that is true, and I can draw these or represent them on a number line. They include minus 2, and they do not include 3 over 2. It's just everything in that interval. Okay, let's try another. This one already has the inequalities written separately, and you might want to figure out the solution set to this pair of simultaneous inequalities by yourself, and then look at the video later and see if you get it right. Okay, so I'm going to label them 1 and 2. 1 is 2 minus x is less than x, and the second one is x less than 0. And we already have the inequalities separated here, so there's no work to be done for that. Now this is linear, so I bring all of the x's to one side. I have 2 is less than, adding x to both sides, it's less than 2x. And dividing across by 2, I get x is greater than 1. That's the solution set to the inequality 1, and the solution set to the inequality 2 we can already read off from the inequality. It's all x less than 0. So the solution set to the simultaneous inequalities 1 and 2 is the set of all x such that x is less than 0 and x is bigger than 1. And now we all know that there are no such x, so this is the empty set. Sometimes we denote the empty set by this null set sign. So this pair of simultaneous inequalities has no solution. There's no x value which simultaneously satisfies both inequalities.